The unit impulse signal del of t is equal to 0 for t is not equal to 0. This is not equal to 0 at t equal to 0, and we have area under this del of t dt is equal to 1 from minus infinity to infinity. Area under del of t dt is equal to 1. Already we have seen. Now what is the value of this integration from minus infinity to t? Del of t dt equal to how much? For t greater than or equal to 0 and t less than 0 and t less than 0. Now for the first case we consider for t greater than or equal to 0. For t greater than or equal to 0, actually this del of t exists at t equal to 0 only. If you consider t is greater than or equal to 0, that is up to this level or this level, then the corresponding integration minus infinity to dt, corresponding del of t dt is equal to 1. Since in this limits the del of t exists, and the corresponding integration is area under this impulse always equal to 1. Suppose for the case for t less than or equal to 0, for the case for t less than 0, now the impulse exists at t equal to 0, and we are considering the limits from minus infinity to t up to this level only. Up to this, at t is less than 0, the corresponding limit from minus infinity to up to this level only we are considering. The corresponding value dt is equal to 0 for t less than 0, 0 for t less than 0, as there is no impulse exist in the given limits from minus infinity to t, so the corresponding value is equal to 0. So finally we can conclude this value is equal to 1. This value is equal to 1 for t greater than or equal to 0. For t greater than or equal to 0, this value is equal to 1, and this value is equal to 0 for t less than 0. T greater than or equal to 0, and this is the region for t less than 0. The corresponding value is equal to 0. And the signal is named as your step signal u of t, and the corresponding signal is named as your step signal u of t. This u of t is a uniform magnitude of one unit in when t greater than or equal to 0, and this value is equal to 0 for t less than 0. This value is equal to 0 for t less than 0. So we can write the step signal u of t, unit step signal we can call unit step signal. Step signal of unit is of 1 unit. Okay, step signal u of t is equal to 1 for t greater than or equal to 0, and this is equal to 0 for t less than 0. Strictly speaking, the option is available like this. Then u of t is equal to 1 for t greater than 0, is equal to 0 for t less than 0, and it is not defined at t equal to 0. Then this answer you have to select. Okay, we have to select. Okay, for speaking, u of t equal to 0 for t greater than or equal to 0. For strictly speaking, the option is available. These two options are available. Then you have to select this answer only, this option only. U of t equal to 1 for t greater than 0, 0 for t less than 0, and not even at t equal to 0. Now, what is the area of this impulse signal? What is the area of the step signal? That is nothing but integration minus infinity to infinity u of t dt equal to how much? Area is nothing but integration only. But the signal is exist from 0 to t only. 0 to infinity u of t dt, 0 to infinity u of t dt is equal to 0 to infinity is equal to u of t 0 to infinity 1 dt down 1 dt is equal to infinity. So area under the step signal is infinity, but amplitude of the step signal is equal to unity. Amplitude of the step signal is unity, and area under this impulse signal is infinity. Whereas the area under the step signal is infinity. Whereas the impulse signal amplitude is going to be infinity. But area under the impulse is equal to 1. Area under this impulse is equal to 1. So if we consider here impulse and step signal, the corresponding amplitude and area, for the impulse signal, amplitude is going to be infinity, but area under the impulse is equal to 1. Whereas the step signal, amplitude is equal to 1 always, and area under this step signal is equal to infinity. Area under this step signal is equal to infinity. Now, what is the value for minus infinity to t u of t dt? What is the value from minus infinity to t u of t dt? From minus infinity to t, u of t dt equal to how much? As u of t exists from 0 to t only, this can be represented as 0 to t u of t dt. 0 to t u of t dt, this value is equal to 0 to t 1 dt. This is equal to how much? Integration of this is equal to 1, and 0 to t, this value is equal to simply t. So we can generalize this value can be represented as the t into u of t, as this exists only for the positive values of t only. Now integration of minus infinity to t is equal to t into u of t, and this is equal to your ramp signal r of t. This is called our ramp signal r of t. What is the area under this ramp signal? If you consider 0 to t, The 0 to infinity t into u of t, 0 to infinity t dt, that is t square by 2, that is equal to infinity, that is equal to infinity. The corresponding signal is your ramp signal. Ramp signal, and this t into u of t as the expression for t into u of t, this is the format y equal to mx only. So as t increases, this linearly it is increases, linearly it is increases. This is your r of t signal. This is your r of t signal. Finally, you can conclude. Finally, we can conclude three basic steps, three basic signals: impulse, step signal, and ramp signal. For impulse signal, del of t is equal to 1 for t. Del of t is equal to 0 for t not equal to 0. This is not equal to 0 for t equal to 0. And integration of del of t dt is equal to 1. And step of signal u of t is equal to 1 for t greater than equal to 0, and 0 for t less than 0. And r of t is equal to t into u of t. R of t is equal to t into u of t. And integration of this del of t minus infinity to t del of t dt is equal to your u of t already you have seen. Is equal to your u of t already you have seen. And if t greater than equal to 0, if t greater than equal to 0, and integration minus infinity to t, u of t dt is equal to your r of t. Your r of t is equal to t into u of t. T into u of t. Then next one, t into u of t. Next one is a Gaussian pulse or Gaussian pulse. Gaussian pulse equal to e to the power minus pi t square. The Gaussian pulse is e to the power minus pi t square. E to the power minus pi t square. F of t they are given as the e to the power minus pi t square. This is your Gaussian pulse. Gaussian pulse. What is the differentiation of the c power minus? What is the shape of the c power minus pi t square? What is the shape of the c power minus pi t square equal to? This is of the bell shape is like this. The shape of this is of the Gaussian pulse is equal to like this. And what is the integration of the signal? And what is the differentiation of the signal? Integration of the signal is equal to minus infinity to infinity. F of t dt is equal to minus infinity e to the power minus pi t square dt. Already we have seen in the previous session, this value is equal to 1. So integration of this is equal to, this is a constant value. Integration of this is equal to constant value. And what about the differentiation? Df of t by dt is equal to simply e to the power minus pi t square into minus 2 pi t. So this value can be represented as the minus 2 pi t into e to the power minus pi t square. This is simply multiplication of this minus 2 pi t multiplication with the corresponding signal e to the power minus pi t square. Our multiplication of these two signals, here this value is going to be infinity, here this value is going to be 0. So overall value is equal to 0 only. And it is slowly increases, and at t equal to 0 this value is equal to 0, and this value is having some value, 0 into something value is equal to 0. First of all it is increases, and finally and then it reduces to 0. Similarly in this part here it is positive, and here value is equal to negative. So here also first of all it is increases and then reduces to 0. This is the shape of this signal. Differentiation of this e to the power minus pi t square. If they ask you, they may ask you what is the shape of the signal e to the power minus pi t square, or what is they will give you the graph f of t is equal to this one. What is the differentiation of this graph? By seeing you should identify this is the graph of the e to the power minus pi t square. E to the power minus pi t square. From that you can do directly differentiation, which is equal to minus 2 pi t into e to the power minus pi t square. Finally you can write the corresponding shape for the integration. Signal is the signum of t. One more signal is the signum of t. As you know u of t is equal to simply signal exists up to this one. Okay, the signum of t equal to u of t plus u of t plus u of minus t. We can represent u of t plus u of minus t. So otherwise we can write simply the signum of t is equal to signum function. Signum of t is equal to 1 for t greater than or equal to 0. This is equal to minus 1 for t less than 0. For t less than 0. So this value is equal to 1 for t greater than or equal to 0, and minus 1 for t less than or equal to 0. Here also the options is available like this. If 1 for t greater than 0, minus 1 for t less than 0, and cannot say the value at t equal to 0, at that answer you have to select. Okay. Strictly sweeping. Okay, if the options is available like this, then it is that. If the options is available equal to 1 for t greater than 0, is equal to minus 1 for t less than 0, cannot say for t equal to 0, not say t equal to 0, then you have to select this answer only. Okay. Right. Signum of t function is equal to 1 for t greater than or equal to 0 and minus 1 for t less than 0. So this can be represented as the u of t plus u of minus t, u of t plus u of minus t, and as u of minus t is equal to u of t minus u of minus t. This u of minus t can be represented as the 1 minus u of t. Upon simplification, this is equal to u of t minus 1 plus u of t. This signum of t plus 1 is equal to 2 into u of t. So u of t can be represented as a 1 by 2 plus 1 by 2 signum of t. 1 by 2 plus 1 by 2 signum of t. Remember this point. Again it will appear in the Fourier series or Fourier transform like that. Fourier transform you may see. Okay, signal function, just remember, signal function is equal to 1 for t greater than or equal to 0 and minus 1 for t less than 0. Minus 1 for t less than 0. How can you write this u of minus t? That you will see in the operation of the signals, no problem. How can you write this u of minus t? U of t, you know. How can you write u of minus t? We see in the signals, operation of the signals, no problem. The reversal property of the signals you will see, no problem. Okay, then from this we can represent like this. This u of minus t is equal to simply your u of one is nothing but total, and this is your u of t. This is what by doing minus of these signals, you have the signal like this, which is called the u of minus. This is your 1 and this is your u of t. 1 minus u of t is equal to your u of minus t. So u of minus t can be written as 1 minus u of t. Upon simplification, you have u of t equal to 1 by 2 plus 1 by 2 signum of t. Directly in the options is available. What is the equation for u of t in the form of signum of t? At that situation, directly you can select this 1 by 2 plus 1 by 2 signum of t. 1 by 2 plus 1 by 2 signum of t. Then next is the operations on the signals. Next, coming to the operation on the signals. Operations of signals. There are two types of operations. One is shifting and scaling. In this shifting we have two types: delay, advance. Very very easy topic. In the scaling we have amplitude time scaling and amplitude scaling. On this delay in this time scaling you have three parts. One is compression, another one is the expanding and reversal. Operation delay is nothing but simply t minus t naught, and advance is nothing but your t plus t naught. That is nothing but f of the signal is equal to, here the signal is f of t. We are doing some operations on the signal f of t. Those operations are shifting operations, scaling operations. See, delay is nothing but f of t minus t naught, and advance is nothing but f of t plus t naught, and the time scaling is nothing but f of kt. Amplitude scaling is nothing but k into f of t. Here amplitude only changes. Amplitude scaling, here only the instance of time only will changes, does not affect the amplitude of the signal. In this time scaling. Here it does not affect the amplitude instance of the signal, time instance of the signal. It affects only amplitude of the signal. This k into f of t. Now compression is nothing but based on the value of k. The signal may compress or the signal may expand. If k is greater than 1, the corresponding signal may be compressed. Now if k is less than 1, f of kt with k is less than 1, the corresponding signal may expand. Okay, if you consider k is equal to minus 1, the corresponding signal is called the reversal signal. K is equal to minus 1, the corresponding signal is called the reversal signal. Here we have say signum of t equal to u of t minus u of minus t. The corresponding u of minus t. If k is equal to 1, if u of kt is if consider u of kt with k equal to minus 1, the corresponding is u of minus t. That is the reversal of the signal. How can you write all these signals? You will see. How can you write the d minus t or everything? In the shifting point of view, just equate to 0. Whatever expression is there, just equate to 0. In shifting point of view, just equate to 0 and add the value of t to the each and every instance of the time. Equate to 0 and add the t value to each and every instance of the time. Add this t to each and every instance of the f of t. Again I am saying to you, each and every instance of the f of t. In scaling point of view, just equate just equate this kt to 1, just equate this kt to 1, this kt is equal to 1 by k or whatever you get, just multiply this 1 by k to each and every instance of f of t, just multiply this 1 by k to each and every instance of f of t, each and every instance of f of t, and then modify the signal in accordingly, modify the signal accordingly. Now if you consider the combination of the shifting and logic, shifting and scaling, the combination of the shifting and scaling, the situation, shifting and scaling situation, two ways you can go. First scaling, first shifting, then go for scaling, first do the shifting operation, then go for the scaling operation, or otherwise first do the scaling operation, then you can go for the shifting operation. In this the recommended procedure is equal to first do the shifting followed by your scaling, Okay, continuous signal in two ways you can go. If you go for the discontinuous signal, you have to follow this procedure only. So the recommended procedure for the combination of the shifting and scaling is the first do the shifting followed by your scaling. After done, followed by the scaling. Suppose for example, the signal is like f of 2t plus 3. This is the combination of the shifting and scaling. First do f of shifting, f of 2 plus f of t plus 3. Then do the scaling. First step equal to f of 2 plus 3. Then do the scaling, which is equal to f of 2t plus 3. If you go in this way, first do the scaling, that is f of 2t, and after that we have to do the corresponding shifting. The corresponding shifting will give you f of 2 into t plus 3 by 2, f of 2 into t plus 3 by 2. This is the shifting, this is the corresponding shifting you have to do. Okay, but the recommended is that you have to go, please go through this procedure only. First do the shifting followed by your scaling, okay. Alright, just we will analyze this procedure by taking some examples. First consider this f of t is equal to, procedure, whatever the question, the same procedure you have to follow. Okay, already if you have idea about this one, means the questions on this model also over. For any question we have to follow this procedure only. For shifting, equate to 0 and add the corresponding t to each and every instance of the time. For scaling, equate that to 1 and multiply the corresponding t value to each and every instance of the time. If you follow the shifting, combination of shifting and scaling, first do shifting, then scaling, already it was over. For practice point of view only, I am giving some questions. Write down this f of t is equal to a simple rectangular signal. If you consider, this is from 0 to 3, 1, 2, the corresponding value is equal to 1, and they ask you to write down f of t plus 3, f of t minus 5, f of 3t, and f of t by 3, f of minus t, 3 into f of t, f of minus 3, f of minus t, 3 into f of t, like that the signal they have given. This you have to write. First thing we have to f of t equal to they have given. Now for f of t plus 3, this is the shifting. The shifting is nothing but just equate the shifting to 0. Equate that part to 0. That is t plus 3 is equal to 0. The t is equal to minus 3. T plus 3 is equal to 0. So t is equal to minus 3. Add this t value to each and every instance of f of t. First I am writing the instance of this f of t as 0, 0. This minus 3 plus 0. So this will become minus 3. This minus 3 plus 1. This will become minus 2. Minus 3 plus 2. This is minus 1. And minus 3 plus 3, this value is equal to 0. Correspondingly at 0 to 1, this is of the signal like this. So from minus 3 to minus 2, we have to write like this. And 1 to 2, this is the signal of this shape of the signal is like this. So minus 2 to minus 1, the corresponding instance are minus 2 and minus 1. New instance are minus 2 and minus 1. Whatever the shape of the signal for the whole instances, the corresponding shape to be retried in the new instance of this time. So minus 1 to 0 are the new instance. The corresponding instances for the old one of the 2 to 3, for the old one of the 2 to 3. So whatever the shape of 2 to 3 is there, that shape you have to retry here. Minus 1 to 0 1, that is only. Not in using the simple one only, f of t plus 3. Not only this one. Total signal of this is simple, no problem. F of t plus, coming to next one, f of t minus 5. T minus 5 is nothing but simply this is always shifting only. For shifting, just equate as t minus 5 is equal to 0. This implies t is equal to 5, add this 5 to each and every instance of this signal, each and every instance of the signal. So you can write this here is equal to t equal to 5 add to this one, the corresponding signal is equal to 5, the corresponding sample equal to 6, the corresponding is equal to 7, the corresponding is equal to 8. From 5 to 6 is equal shape is like this, 6 to 7 shape is 6 to 7 shape is like this. And for 7 to 8, the corresponding shape is equal to, the corresponding shape is like this. Okay, of this shifting and scaling, there is not affects any amplitude, not affects the amplitude of the signal. Simply the signal may go forward or simply the signal may go backward. Simply the signal may go backward. So this is called, this is signal to be started from t equal to 0. In here, the signal already started at t equal to -3. So this is called the advanced nature. This is called the advanced nature. Here the signal should start at t equal to 0, but signal starts at t equal to 5, so it is delayed by 5 units. Delayed by 5 units, so called the delay nature. This is called the delay nature of t minus 5. So if the shape is of the form f of t plus t naught, if shape is of the form f of t plus t naught, then the corresponding is called the advanced signal, advanced nature. If of t minus 5, the corresponding is of the delay nature, corresponding is of the delay nature. Okay, coming to f of 3t. F of 3t, it is a scaling property. In scaling, we have to do 3t is equal to 1, the corresponding t is equal to 1 by 3. We have to multiply this t equal to 1 by 3 to each and every instance of this, each and every instances of the signal. Instances of the signal. Now I am writing the new instances. 1 by 3 into 0, which is equal to 0. 1 into 1 by 3, the corresponding is equal to 1 by 3. 2 into 1 by 3, corresponding is equal to 2 by 3. And 3 into 1 by 3, corresponding is equal to 1. So 1 to 1 by 3, the shape is of like this. From 1 by 3 to 2 by 3, the shape is of like this. From 2 by 3 to 1, the shape is of like this. The shape is of like this. So the corresponding here, what is the width of this? Width of the original signal. Width of the original signal is equal to 3. Here the width of the original signal becomes, original signal becomes 1. So width is reduced. Yes, the corresponding signal is compressed. The corresponding signal is compressed. So here above k is greater than 1. Here this k is greater than or equal to 1. So the corresponding signal is compressed. K is greater than 1. The corresponding signal is compressed signal, and width becomes width divided by 3, and width becomes width divided by 3. Original width divided by 3. So original width is equal to 3. We have here the width is equal to 1. Here 3 by 3, that is equal to 1. Now coming to f of t by 3. Here also scaling only. So equate the t by 3 to equate that to t by 3 to 1. So corresponding t is equal to 3. So multiply with t equal to 3 to each and every instance of that signal. The corresponding signal is equal to 0, 3, 6 and 9. 0, 3, 6 and 9. So 0 to 3, this value is of like this, and 3 to 6, this shape is equal to like this, and 6 to 9, the corresponding shape is equal to like this. Simple question. So this is equal to f of t divided by 3. F of t divided by 3. Here what is the width of the signal? Here width is equal to, here width dash is equal to 9. Here width dash is equal to 9. Width into 3. Original width is equal to 3. The new width is equal to 9. So this is equal to 3 into 3, which is equal to 9. Now coming to f of minus t. F of minus t also scaling only. So equate is minus t equal to 1 and t equal to minus 1. So multiply each and every instance of this time with t equal to minus 1. So 0 will become 0 only, and for minus 1 it will become minus 1. 2 it will become minus 2, and 3 will become minus 3. This simply shape is equal to like this only. This is your f of minus t. This is your f of minus t. In earlier we have u of t equal to like this. U of t is equal to like this, and they ask you to write the u of minus t. They ask you to write the u of minus t. This is your u of t. They ask you to write the u of minus t. U of minus t is nothing but the scaling only. T equal to minus t is equal to 1 and t equal to minus 1. We have to multiply this minus 1 to each and every instance of this time, and consider some instance 1, 2, 3 like that. The corresponding will become minus 1, minus 2, minus 3, and the value will shape is become like this. This is equal to u of minus t. Okay, this is your u of minus t. So because of this, we have written the signum of t equal to u of t minus u of minus t. Signum of t equal to u of t minus u of minus t. U of minus t. No problem. Coming to this way, this one. What is the last one? 3 into u of t. That is the amplitude scaling. Okay, it is not affecting any changes to the instance of this time. This 3 into f of t will simply it multiplies the amplitude only. So this will become your 3 into f of t. 3 into f of t. 0, 1, 2, 3. 0, 1, 2. This is called the amplitude scaling only. 3, 0, 0, 1, 2, 3. Now coming to one more question, if you consider. One more question. The signal f of t is given as, okay, whatever the procedure is same procedure only. This is only if shifting, equate to that. If scaling, equate to that, equate to the 1 and multiply to all the instances. Consider this person. -1, 0, 1, 2, 0, 1, 2. If some irregular shape is there, then you have to concentrate. You have to concentrate. 0, -1, 0, 1, 2. They ask you to calculate. They ask you to write down the f of 2t plus 2, f of 2t plus 2, f of minus 3t plus 2, f of minus 3t plus 2, and one more signal. -1, 1, 2, 3. Here is 1, here is 2. This is your f of t. They ask you to write down the f of minus 2t plus 5, f of minus 2t plus 5. These two you have to write. This is the combination of the shifting and scaling. This is the combination of the shifting and scaling. So we have to the first procedure you have to follow. Recommended procedure is equal to first do the shifting, then followed by the scaling, then followed by the scaling. First do the shifting. First to try to do the shifting. First do the shifting. The shifting corresponding signal is equal to f of 2t plus 2. F of 2t plus 2, the corresponding shifting point of is equal to f of t plus 2. F of t plus 2 nothing but t plus 2 equal to 0 and t equal to minus 2. You have to add t equal to minus 2 to each and every instant of the signal. First I am adding the instances. The corresponding t equal to minus 2. This will minus 1 will become minus 3, 0 will become minus 2, 1 will become minus 1, and 2 will become 0. 2 will become 0. The corresponding whatever the shape from minus 1 to 0, the corresponding shape to be exist from minus 3 to minus 2, and whatever the shape of 0 to 1 to be exist from minus 2 to minus 2 to minus 1, minus 2 to minus 1. Whatever the shape for 1 to 2 should be present from minus 1 to 0, should be present from minus 1 to 0. Simple, go through this one here. First write down the instances, then draw the shapes, whatever the shape is existing in the previous instances, corresponding shape will be present in the new instances. Now coming to your scaling. Scaling is nothing but simply f of 2t plus 2 here, f of 2t plus 2, that is nothing but simply 2t is equal to 1 and t is equal to 1 by 2. You have to multiply this t equal to 1 by 2 to each and every instance of this signal. Okay, from this signal you are writing, okay, this is equal to f of t plus 2, f of t plus 2. From this signal you are writing the scaling. You are writing the scaling, so you have to multiply this t equal to 3 by 2 to each and every instance of this signal. So this will become minus 3 by 2, this will become minus 1, and minus 1 by 2, and here is equal to 0. So the shape is equal to exactly like this only, but the same shape is is there, but it should be compressed. Here width is equal to 3, here width is equal to 3 by 2, here width is equal to 3 by 2. Now if you do the procedure first scaling, then shifting, how it will be, we will see. First scaling is nothing but we have to write down the f of 2t. F of 2t nothing but first we have to write down the corresponding instances. 2t is equal to 1 and t equal to 1 by 2. T equal to 1 by 2. So 1 by 2 to be multiplied with each and every instance of that signal f of t. So this will become minus 1 by 2, 0, 1 by 2 and 2 by 2 is equal to 1. So the shape of the signal is equal to like this same shape only, but the width will be reduced. Earlier width is equal to 3 and now width is equal to 3 by 2. Now width is equal to 3 by 2, 1.5. Now f of 2t. Now after that you want f of 2t plus 2. F of 2t plus 2. That is nothing but simply by taking this 2 as the common, this will become f of 2 into t plus 2. By taking this 2 as common, this is simply f of 2 into t plus 1. 2 into t plus 1. Now we have to shift this signal according to t plus 1. By taking this t plus 1 is equal to 0, the corresponding t equal to minus 1. The corresponding t is equal to minus 1. So we have to add this t equal to minus 1 to each and every instance of the signal. Each and every instance of the signal, this will become this minus 1 by 2 will become minus 3 by 2. This 0 will become minus 1. This 1 by 2 will become minus 1 by 2. And this 1 will become 0. 1 will become 0. So the shape of the signal is. So the shape of the signal is like this. This is only the signal f of 2t plus 2, f of 2t plus 2. Whatever this procedure you may go or this procedure you may go. But recommended, already I again told you, recommended procedure is equal to f of 2t plus 2. This one, because in discontinuous signal the operation is about the scaling and shifting. We have to follow this procedure only. First shifting, then scaling. First shifting, then scaling. Because if you do the first shifting, some sample values may roll out. Those may not appear in the final signal. Before writing the final signal only, some sample value may be rolled out. If you do the scaling, okay, so on that situation you have to go only the shifting followed by the scaling. At that situation again we will discover the reason why you have to consider this only again in the discontinuous part, in the discontinuous signal we will discuss, no problem. No problem. Now coming to next one, f of minus 3t plus 2, f of minus 3t plus 2. First I am writing the normal procedure, which is equal to f of t plus 2. First I am writing this f of t plus 2. T plus 2 means t plus 2 equal to 0, t equal to minus 2. This is reduced to minus 2. You have to add t is equal to minus 2 to each and every instance of the signal. This will become minus 3, minus 2, minus 1 and 0. Minus 1 and 0. So the shape of the signal is equal to like this. This is our f of t plus 2. Already we have drawn. From this, now we have to write f of minus 3t plus 2. This is f of minus 3t plus 2. Simply equate this minus 3t is equal to 1. Simply equate this minus 3t equal to 1. T is equal to minus 1 by 3. T is equal to minus 1 by 3. Multiply this t equal to minus 1 by 3 to each and every instance of the signal. Each and every instance of the signal. This minus 1 by 3 will become. This minus 1 by 3 will become your 1. This minus 2 into this minus 1 by 3 will become 2 by 3. It will become 2 by 3. This minus 1 into minus 1 by 3. The corresponding will become 1 by 3. Corresponding will become 1 by 3 and 0 into this is equal to complete 0 is into this one equal to 0. Now listen how I am writing this up to this signal 0 to 1 by 3 is nothing but corresponding to distances minus 1 to 0 so we have to write like this. From 1 by 3 to 2 by 3 is corresponding to this part corresponding to this part. At t equal to minus 1, the shape of the signal is equal to like the shape of the signal is equal to like this, and yes, t equal to minus 2, the shape of the signal should be like this, because drawing of the signal is very important here. Okay, whatever the shape at the previous instances, that same shape to be right in the new instances. In any way you can write. So here this 1 is correspond to minus 3. The new instant 1 is correspond to minus 3 and this 2 by 3 is correspond to minus 2. So from minus 3 to minus 2 the same shape should be drawn from 2 by 3 to 1. 2 by 3 to 1. Now at this minus 2 is correspond to your 2 by 3. This minus 1 is correspond to 1 by 3. At minus 1 you have the peak value, so you have to consider the peak value at 1 by 3. You have to consider the peak value at 1 by 3. Somebody may draw like this. Somebody may draw like this by considering the signal is equal to by considering the peak value at 2 by 3. Peak value at 2 by 3 and like this they may draw. Okay, be careful. Here the peak value at minus 1, the corresponding new instant only there should be a peak value. Okay, corresponding new instant equal to 1 by 3, so peak value is equal to here only. At 2 by 3 this value is equal to this value reduces, so a corresponding value is like this. Like that you have to analyze what are the new instances, what is the amplitude at the old instant. At the old instant the same amplitude to be repeated at the corresponding new instant. Got it? Because in the shifting and scaling there is no change in amplitude of the signal. Whatever the amplitude in the old instant should be appear in the new instant also. Just keep that point only. You may kill any question. Now we'll do the same question in the form of the scaling then shifting. First I am writing f of 3t. I am writing the corresponding signal f of 3t equal to simply t equal to minus 1 by 3. This will become minus 1 by 3. This is 0. This is 1 by 3 and this is 2 by 3. The corresponding signal will become like this. This is your f of 3t. Now, how can you write the signal f of minus 3t plus 2? If you write f of minus 3t also, if you are interested about writing minus 3t also, it is simply this minus 3t. Simply you are writing minus 3t only, not doing anything. Simply you are reversing the signal only. So 1 by 3 will become minus 1 by 3. Minus 1 by 3 will become 1 by 3. This 2 by 3 will become minus 2 by 3 and this 1 by 3 will become minus 1 by 3. This 1 by 3 will become minus 1 by 3. So 0 to 1 by 3 how the shape is equal to like this, and 1 by 3 to 2 by 3 corresponding to minus 2 by 3 equal to this shape is equal to like this shape to be like this. And at 1 by 3 this value you are having the peak value. At 1 by 3 you are having the peak value. Those corresponding peak value you have to consider like this, and this is to be reduces like this. This is your f of minus 3t. From this we have to write the signal f of minus 3t plus 2. F of minus 3t plus 2 means we have to represent this equal to minus 3 into t minus 2 by 3. Minus 3 into 2 minus 2 by 3. The corresponding signal is equal to minus 3t. Upon multiplying this 3 to internal, this will become minus 3t plus 2 only. If you are having any confusion of writing like this, Simply equate with minus 3t plus 2 equal to 0. Simply equate that minus 3t plus 2 equal to 0. So minus 3t equal to minus 2 and t equal to 2 by 3. T equal to 2 by 3. Here t equal to 2 by 3 means in the signal point of view you have to write t minus 2 by 3. T minus 2 by 3. In f of t plus 2. In f of t plus 2. This t plus 2 equal to 0. T equal to minus 2. If you have t equal to minus 2, the corresponding signal is delayed signal. The corresponding shifting signal equal to f of t plus 2. Here you got t equal to 2 by 3. There should be the corresponding. Got it? So the corresponding signal should be the operation on the signal should be f of minus 3 into t minus 2 by 3. T minus 2 by 3. Got it? Like this also you can write. Like this also you can write. Simply write the f of minus 3t equal this to 0 and t equal to 2 by 3 means the corresponding equal to f of minus 3 into t minus 2 by 3. So you have to add this t equal to 2 by 3 to each and every instance of the signal. We have to add t equal to 2 by 3 to each and every instance of the signal. I am adding the new instances 2 by minus 2 by 3 plus 2 by 3 equal to 0. 2 by 3 minus 2 by 3. 2 by 3 minus 2 by 3 equal to 1 by 3. And 2 by 3 plus 0 is equal to 2 by 3. And 2 by 3 plus 1 by 3 is equal to 1. So these are the new instances. The corresponding old instances are minus 2 by 3 to minus 1 by 3. So signal should be of the like this. Signal should be of like this. And from 1 by 3 to 2 by 3 signal should be of like this. And then 2 by 3 to 1. This is your signal. This is of the way of writing in this f of minus 3 into t minus 2 by 3. This is the signal f of minus 3t plus 2. This is the signal f of minus 3t plus 2. Okay, this is the signal f of minus 3t plus 2. Of this, the easiest way is this one only. This is also the easiest way. Nothing is there. First write f of minus 3t and equal the given expression minus 3t plus 2 is equal to 0. T equal to 2 by 3. This will become the delayed nature. This is equal to minus 3 into t minus 2 by 3. Like this also we can write. Simply take this minus 3 as a common. After writing this f of minus 3t, simply take this minus 3 as a common. We get t minus 3 of t minus 2 by 3 only. Many ways we can write. In many ways we can write after getting this one. Okay, equate this total this internal part only. Okay, you are modifying this signal t. This signal you are making the delay. This signal you are making the delay. So t minus t by 3 equal to 0 and t equal to 2 by 3. By adding this 2 by 3 voltage instances, you will get the original signal. You will get the original signal. For practice point, I will take that question. For practice point, I will take that question. F of t equal to something they have given. The shapes are different shapes are there. So you have to be careful. But retrying the new shapes, whatever the value existed the old instances, the corresponding value to be considered in the new instances. Nothing is the corresponding value to be considered in the new instances. Here, what they have given f of t, what they are asking f of minus t. What they are asking f of minus 2t plus 5. Okay, first I am writing f of t plus 5. Directly I am writing this nothing but t plus 5 is equal to 0, t equal to minus 5. So this minus 1 will become minus 6, this minus 1 will become minus 6, 0 will become minus 5 and 1 will become minus 4, 2 will become minus 3, 2 will become minus 3 and the 3 will become minus 2, 3 will become minus 2. This is the new instances. These are the new instances. From minus 6 to minus 5 is the corresponding region is equal to this one. So whatever the shape is there, the corresponding shape you have to consider like this. And minus 5 to 4, the corresponding shape is equal to like this only. And 1 to 2, we have the shape is equal to like this. And at 3 to minus 2, we have the shape is equal to like this. Shape is equal to like this. Now what they are asking now, f of minus 2t plus 5. From this we have to write the f of minus 2t plus 5. Minus 2t plus 5 is nothing but simply equate minus 2t is equal to 1. Simply equate minus 2t is equal to 1 and the corresponding t equal to minus 1 by 2. You have to multiply this t equal to minus 1 by 2 to each and every instance of the signal. So minus 6 into minus 1 by 2, this will become 3. Minus 6 into minus 1 by 2, this will become 3. And minus 5 into minus 1 by 2, this will become 5 by 2. This will become 5 by 2. And minus 4 into minus 1 by 2, this will become your 2. And minus 3 into minus 1 by 2, this will become 3 by 2. This will become 3 by 2. And minus 2 into minus 1 by 2, this will become 1. This will become 1. Then again draw the shapes. This 3 to 5 by 2. This 3 to 5 by 2, 3 is the corresponding instant equal to minus 6. So we have to consider here is equal to 0 and at 5 by 2 the corresponding instant, suppose the amplitude is equal to 1, we have 1 if they here, 1 if they here. So from 3 onwards it is slightly increasing and up to reaches the value 1, which is the value 1. So we are constantly increasing and reaches the value is equal to 1. And at 5 to this minus 4, this value is constant at 1 only. So this value should be constant at 1 only. At minus 4, suddenly raises to 2. So at 2 we have to raise to 2 value. And this is constant up to minus 3. So we have constant up to minus 3 by 2. At minus 3 by 2, it suddenly drops to It suddenly drops to some minus 2. I am considering. It suddenly drops to some minus 2. Some minus 2. And from minus 2 onward, again it is going to be 0. It is going to be 0 at 1. Going to be 0 at 1. This is the way of drawing the signal f of minus 2t plus 5. Right. Now I want to go in a different procedure. Then first we have to write the f of minus 2t. F of minus 2t. That f of minus 2t is nothing but simply minus 2t equal to 1, t equal to minus 1 by 2. This is to be multiplied with the original signal. This is to be multiplied with the original signal. Then this minus 1 will become 1 by 2. This minus 1 will become 1 by 2. And the corresponding 0 will become 0 only. Corresponding 1 will become minus 1 by 2. And corresponding 2 will become minus 1. And corresponding 3 will become minus 3 by 2. Corresponding 3 will become minus 3 by 2. Now how to draw? At minus 1 we are having the value equal to 0. So the corresponding value should be equal to, here is equal to 0. And this slightly increases to value 1. Increases to value 1. And it is constant up to this value. After that it is raising to value 2. And constant up to this one. And after that it is falling to minus 2. And again reaches to 0. Again reaches to 0. This is the expression for f of minus 2t. F of minus 2t. Now we have to write the required signal. F of simply taking this minus 2 as a common, this will become minus 2 into t minus 5 by 2. Minus 2 into t minus 5 by 2. This is equal to f of minus 2t plus 5 only, right? F of minus 2t plus 5 only. So this signal we have to shift. We have to delete. This is the delayed version of the signal by the 5 by 2 unit. This is the simply delayed version of the signal by the units 5 by 2 units. So this t minus 5 by 2 is equal to 0. This t minus 5 by 2 is equal to 0 and t is equal to 5 by 2. This 5 by 2 value to be added to each and every instance of the signal. Each and every instance of the signal. Now what will happen? We will see. Listen. This 5 by 2 minus 3 by 2 plus 5 by 2. What is the value? Equal to 1. Equal to 1. And minus 1 plus 5 by 2. Minus 1 plus 5 by 2. Minus 1 plus 5 by 2. This value is equal to 3 by 2. The corresponding value here is equal to 3 by 2. And minus 5 by 2 minus 1 by 2. The corresponding value is equal to 2. Corresponding value is equal to 2. And 5 by 2 plus 0. Corresponding value is equal to 5 by 2 only. And 5 by 2 plus 1 by 2. Corresponding value equal to 6 by 2. Corresponding value is equal to your 3 only. Your 3 only. How to draw? This is simply the delayed version of the signal only. Delayed version of the signal only. So the shape is also simply like this. Same shape will appear like this. The same shape will appear like this. This is your original signal f of minus 2t plus 5. This is your f of minus 2t plus 5. Like this you have to draw. Nothing is there. First draw the new instances and redraw the shape. Whatever the shape exists for the old instances, simply transfer. If you are having any confusion, consider some amplitudes. If you are having any confusion, consider some amplitudes. And regardingly you can write. So you can write the corresponding new signal. Now write down the expression for the del of t minus 5. Del of t minus 5, del of t plus 5. Del of t minus 5, del of t plus 5 and del of 2t. And del of 2t. The same shifting operation with respect to the impulse. Del of t plus 5, del of t minus 5. Del of t plus 5. Del of simple question, write down. Del of t minus 5 and del of 2t. Del of 2t. And del of 2t. Del of t plus 5 is nothing but simply the signal del of t equal to exists only at t equal to 0. Exists only at t equal to 0. Strength is equal to 1. Okay, nothing is mentioned in nothing but the strength is equal to 1. Not in amplitude, that is area. Strength is equal to 1. Then so del of t plus 5 is nothing but simply t plus 5 equal to 0 and t is equal to minus 5. This simply shifted to the signal minus 5. Simply shifted to the signal minus 5. And this is your del of t plus 5. Del of t plus 5. What about this del of t minus 5? What about this del of t minus 5? Del of t minus 5 means t minus 5 equal to 0. Add this t equal to 5 to the other signal. This will become the impulse at the t equal to 5 like this. T equal to 5 like this. What about this del of 2t? Del of 2t is nothing but simply multiply. 2t is equal to 1. Simply consider 2t is equal to 1. 2t equal to 1 and t equal to 1 by 2 you have to consider. T equal to 1 by 2, t equal to 1 by 2 you have to write. So 1 by 2 to multiply with the instance of this original signal at t equal to 0 only. At t equal to 0 only. So we have the signal is like this only. But in the scaling, it may not affect the amplitude. In the scaling, it may not affect the amplitude. So the corresponding amplitude is equal to some infinity only. Here, the scaling. Listen carefully. Scaling may not affect the amplitude of the signal, but it affects the width of the signal, right? Width of the signal. Here the original width is equal to a, then the new width will become a by 2 because 2 is greater than 1. 2 is greater than 1, the signal should be compressed. Original width is equal to A, the new width is equal to A divided by 2, A divided by 2. If you consider the area point of view, where impulse was generated from the unit area, rectangular pulse, this is minus A by 2 to A by 2, minus A by 2, A by 2, this is equal to 1 by A. This is the signal you have considered, is A into 0. Here the width is equal to A, here width is equal to A, corresponding area is equal to 1 by A into A, which is equal to 1, right? 1 by A into A is equal to 1. Now here the width becomes A by 2, right? Clear? Width becomes A by 2. That is, signal is compressed to A minus A by 4 to A by 4 minus A by 4 to A by 4. The corresponding signal is equal to this one. What is the area of this signal? This area is equal to simply 1 by A into A by 2, which is equal to 1 by 2. Area is equal to 1 by 2. So, as limit A tending to 0, the signal can be represented as a 1 by 2 into del of T. Right or wrong? Right or wrong? Here the amplitude may not changes, but area is going to be changes because the width is reducing. Here the amplitude is equal to 1 by A1 I am considering. 1 by A1 I am considering that as width is reduces to 1 A by 2. So because of this width is reduces, by making this amplitude as constant, area is going to be 1 by 2. Area is going to be 1 by 2. 1 by 2. So the signal will be represented the corresponding strength of this impulse is equal to 1 by 2. 1 by 2. Again I am saying to you in the previous class also I told you many times, it is not a amplitude. This is strength of the impulse or area of the pulse. Okay, here scaling and scaling, there is no change to the amplitude, but here it is the area of this impulse, area of the strength of the impulse. So this may changes, this may changes because of changes in the width of the signal. Changes in the width of the signal, and changes in the width of the signal, the corresponding area will be changes. The corresponding area here is equal to 1 by 2, and the corresponding signal you can call as a 1 by 2 into del of T. Corresponding signal you can call the 1 by 2 into del of T. Del of T. If I am considering del of minus 2t, this is your signal del of 2t. This signal del of 2t is equal to 1 by 2 into del of t. If I am writing now del of minus 2t, I am asking write the del of minus 2t. Write the del of minus 2t. Del of minus 2t also will become. This is the original impulse of the signal, like A tending to 0. This is the original impulse of the signal. For this, if you write minus 2t, this is your del of 2t signal. This is your del of 2t signal. This is your del